Hello students, today is the day to begin with a topic, and that is one topic which you experience every day, knowingly, unknowingly, but there cannot be even a single day that you do not experience it. What is it then? I am talking about sounds. Don't you listen to the sounds right from the moment you get up in the morning? Some kind of sounds, whether your mom is calling you, or whether some bell is ringing, some alarm is ringing, or birds chirping outside and so on. Your morning begins with sounds, and so is true even till the time you fall asleep. So complete day is filled with sounds. Even now I am talking to you, that means I am sharing sounds with you. Or I am also listening to some sounds from outside, some motorcycles and bikes, they are making some honking and everything. So sounds are around us. There cannot be life without sounds. Let us know something more about what is sound. Basically, what is sound? This question is very funny. You may say sound is sound, what else to talk about? But technically sound has some definite meaning, some definition. See, sound is one form of energy produced by some force that causes some vibrations. Vibration is nothing but moving back and forth. So that is vibration. So some energy which produces vibrations, this is nothing but sound that is produced, which is carried further by a medium like air. So air is around us. So these vibrations become waves in the air and they are carried to some distance. Say if I shout at this place, my sound of shouting or voice can be taken to some distance like 100 meters. Because my energy which I have totally given to this sound, these vibrations I am creating, they are given to air, and air is carrying those vibrations. They cannot go beyond say 100 meters or maybe little more than that. Aeroplane, when it is flying over your head, you can hear it or listen to its sound from few kilometers. So likewise, depending on what is the energy that is being poured into sounds, it is transmitted through the medium. Now the medium I am talking about, what is that medium? Some kind of substance which can take those vibrations forward by some movements. Those movements are called as waves, and those waves are carried up to a distance through this medium. Does that mean that air is the only medium to take sound like this? No. Sound can travel through gases like air, through liquids like water and any other liquid, and through all solids. We often think that air takes sound and propagates it or transmits it from place to place. And that is the fastest perhaps. You might think so. But no. Water carries sound by more than 3 to 4 times the speed of air that sound travels in. So sound travels much more faster in water, and sound travels up to say 15 times faster through metals like steel. So ordinarily you will find sound travels about 340 meters per second, or maybe about 1200 kilometers per hour in air. This is about air. But if I think of say steel, the same speed is about 5000 meters per second approximately. And in water also it is 4 or 5 times more than this. I mean, what is speed of sound in air? So sound travels in different mediums. We'll see that when we do some experiment as well. Okay, so this is something known to us now. I told you sound produces waves. We often see waves on sea. As you look at the sea, you often feel there are waves traveling up and down. So, like this. These are the waves we often see on water. Are they similar to waves of sound? Yes, that way waves are waves. But structurally, these waves are different than sound waves. See, look here, wave is traveling in this direction. I mean, actual direction of propagation of wave or traveling of wave is this, and wave is moving up and down while it is traveling in this direction. That means molecules of this wave, say these are molecules, they are moving up, moving down, moving up, moving down. So molecule movement is up and down, and wave motion is perpendicular to that. Perpendicular, that means in 90 degrees. This is a molecular motion, this is a wave motion. This type of wave is wave on water surfaces, or that way you have heard that light also travels like waves. So light waves are like this. They are called as transverse waves. Transverse waves. So this is transverse wave. And then how does sound travel? The wave is little different. What happens when a vibrating object creates pressure kind of sequence on medium around it, like high pressure, low pressure, high pressure, low pressure? That, as I told you, it's a vibration moving back and forth. So when it moves forward, it creates some kind of pressure on the surroundings, and the pressure is reduced when that vibration comes back. So it vibrates, and these vibrations produce back and forth waves. So molecules, they compress, come close, and again when this wave goes back, these molecules decompress or rarefy. So there is a sequence of compression, rarefaction, compression, rarefication, compression, rarefication. So the term is called as compression and rarefication is what keeps happening in sound waves. I'll just show it pictorially. See, these molecules come close, they go away. Come close, go away. Come close, likewise. So this is compression and this is rarefaction. It's a rarefaction. So compression and rarefaction keeps happening every alternate, and this wave propagates or travels. That means these molecules are moving in the same direction that of propagation of sound. So sound travels in this direction, molecules also travel back and forth. Here it was different. Molecules were traveling up and down, and wave was traveling this way. Here direction of both is same. Such waves, they are not now transverse waves. They are called as longitudinal waves. Longitudinal waves. Right? So, very fundamental thing that, okay, the travel of sound is like waves, but these waves are longitudinal waves, and the waves of light or waves which are seen on surface of the sea are transverse waves. Okay, so this is something little technical, but maybe you can start appreciating that science of small things also has a lot to learn from. Okay, now this is about sound waves. This topic we have to discuss in two different sessions, because sound topic though appears to be very common around us, but how do we produce sound, how do we listen, how much can we listen, what is the minimum, what is the maximum you can listen to, and so on. All such things need to be understood. So we have split it in two different sessions. Today I will talk something more about how do we make sounds and how do we listen. Little bit about that. Each creature, or the animals particularly, can listen. Even plants also do listen, but more specifically animals listen to sounds and they respond to those sounds as well. As a human being, we listen to sounds which are in a specific range. That means if some sound is too low, we cannot listen to that. And some very high pitch, shrill sounds, beyond the limit we cannot listen. Now these are nothing but number of oscillations per second. That's what is referred to as frequency of sound. That means if my heart is beating say 70 times per minute, that means simply 1.2 times per second, because there are 60 seconds in 1 minute. So frequency of my heart's beats is just 1 or 2 beats per second. Just 1 or 2 beats per second. Now, I think you are understanding the concept of frequency. How many times same thing is repeating? That is a frequency. We can listen to vibrations which are at least 20 times per second. The waves created by vibrations which are at least 20 times per second. That is the minimum limit that we can listen to. So 20 is the minimum. 20 vibrations per second is the starting point. If there are less vibrations per second, our ears cannot capture or catch them. So from 20 to 20,000 number of vibrations per second. Or if I use some technical terms, this is measured in terms of hertz. This frequency is measured in terms of hertz. So from 20 hertz, I'll just write H or Hz to 20,000 hertz. You know, like we say gram and kilogram, 1000 grams make 1 kilogram. Similarly, 1000 hertz will make 1 kilohertz. So that means I can say 20 hertz or 20 kilohertz. Okay, this is the range, 20 hertz to 20 kilohertz. That's what we can hear the sounds up to. Many animals have some different ranges like this. I'll just take an example of a dog. Dog can listen frequencies far beyond this, even go up to 40,000 hertz. So you may find that dog suddenly raises its ears. Ears of dogs, they stand up because dog might be listening to some frequencies which we cannot listen to. We don't sense anything, any sound around it, but dog senses some sound. But dog is deaf up to 40 hertz. That means at lower end, we are better than dog, and at the higher end, dog is far more better than us. So every creature has some different range. You may find that out. From using some Google, you can easily find out range by that whale and bats. So many things. You can definitely find it out. So far is right that we have understood that we have some limitations of listening. Frequency of 20 hertz. That means 20 times if something vibrates and produces waves, we can listen, not below that. However, this ability changes by age or person to person. It may not be exact. It is generalized way of talking about it. Now I am talking to you. That means I am making some sound using my sound box. making sounds is a very natural kind of quality that every one of us possesses. A young baby produces sounds, but it is not meaningful sound. Like I'm talking to you in some specific language, articulating words, communicating with you, and you are understanding the meaning of what I'm trying to say. But young baby makes some funny sounds because young baby also has this sound box, but that is not so far well groomed, trained by the brain and trained by maybe mother of a child and so on. So child knows making of some sounds, funny sounds. How these sounds are made? Basically we use lungs air. That air uses some passage, which is a common passage. Some part of it is common for even food and air, and then it splits here, and larynx takes air into lungs and throws air out from lungs, and this your esophagus takes food and water down. So windpipe starting from larynx throws air out, and in this sound box or around this part of your this area of your chin or below your chin, we have two vibrating thread-like structures. They are called as vocal cords. There is a gap between these vocal cords. They are muscular thread structures. Air passes through these two threads, and these threads vibrate, and vibrations of any object produces waves, and these waves are sound waves. Basically you know how to vibrate them because you are now trained to do that. A newborn baby doesn't know how to vibrate them exactly to communicate some meaningful communication. So funny sounds are produced by a baby, whereas we produce meaningful sounds. But you can practically sense these vibrations. Do one simple thing. Put your two fingers, index finger and your thumb, around this Adam's apple here at this point, and start uttering any sound. Like you may keep talking like this, or you may chant something like Om or anything. You will find that your fingers sense some kind of vibrations inside. So these vibrations are nothing but sound produced by these two vocal cords, and then those sounds further articulated by your mouth cavity, your tongue, your teeth and so on, and meaningful communication is given out, and somebody can listen to that and can understand that. So that's why we produce sound, using air from lungs thrown through this windpipe, and while it is coming out through your mouth, it vibrates those vocal cords, and these vocal cords, which are stretched kind of two strings, they vibrate producing sounds. Right? We have understood how sounds are produced. I'll just add something, how do we listen to the sounds, and then we'll go for activities for today. So when sound, that air around you carries sound spoken by maybe your friend little away from you, that air comes close to you, travels into your ears as well, and inside your ears there is a fine membrane or something called as eardrum. These vibrations hit onto the eardrum, and these eardrums in both the ears start vibrating. These vibrations of eardrum are carried to inner ear through three small bones or ossicles. Bones carry the vibrations. They are made little finer, and they are given to inner ear, which has a structure like a snail, like this. This is called as cochlea. So this snail-like round structure has lot of hair-like structure. These hair-like structures have some kind of, I could say, some structure which is similar to pollen grains, like some kind of grain structure on top. these hair cells, they oscillate as the waves of sound waves, they strike onto these hair cells, and this structure also oscillates and produces electrical signals. These are called stereocilia. So let us not get into the terms right now. So stereocilia, they vibrate and electrical signals are produced and they are carried to brain. This electrical signal is carried to brain. So sound waves is converted to electrical waves and electrical waves are carried to brain through hearing nerves. And brain then interprets, understand that sound is of, it's a human sound or some natural sound like maybe thunderstorm or earthquake or wind or whatever, or sea, tides, all such sounds are recognized by your brain and it understands them. If I am talking some language, brain understands that language and then responds. So how sound wave is understood, or you listen to sounds, wave travels, hits the eardrum, eardrum gives it to ossicles or some bones, very small bones, smallest bones of your body, they are in your ears. This goes to inner ear like cochlea. Here we have hair cells with stereocilia, they vibrate. These vibrations produce electrical signals that are taken to brain and then brain understands sound waves. So how do we talk? How do we listen? Two things we have understood today. We have also understood that sound is a wave. There are types of waves like longitudinal waves, there are the sound waves, and light waves are transverse waves going up and down and traveling in horizontal direction. So we have understood that human ears have some limitations. From 20 Hz to 20,000 Hz is a range that we can listen, and that range is called as essentially sound, because that is what we understand. Other sounds anyway we don't understand, so we don't call them sounds, right? Because they are not understood by us. In the first activity, I will use this plastic strip and we will vibrate this strip by plucking it. Now let us see, these vibrations will definitely produce some sound. But one more thing I want to show, and you also wish to try. If I take a long part of this strip out from this table and pluck it, then the sound will be altogether different. And as I keep reducing this area outside or projecting out from the table, if I keep reducing like this, sound will be altogether different. Why? We'll discuss in next theory session that what happens exactly, that sound pitch changes with the length. We'll discuss this definitely, but right now let's enjoy and see that how vibrations produce sound. I'll take to the edge of this table. I'm holding my one finger on this plastic strip. It's gripped tightly. You may use even thumb if you wish, or 2-3 fingers together, and pluck the other end and listen to the sound. Now I will not make any sound, just listen, I'll keep changing the length and see how is the result. Listen. I'll go in reverse direction now. So we made variety of sounds with single string, and you must have noticed that the sound changes with the length projecting outside of the table. Let us know the reason later. We'll move on to the next. We spoke about the traveling of sound through different mediums. Can sound also travel through thread or a string? Of course, yes, it must, it should. Sound can travel through any medium. Rather, it travels better through other mediums than air. To test that, we'll make a simple phone, typically called as a string phone, or sometimes also called as shepherd's phone, because perhaps shepherds were using it to communicate or to play when they were on their duty. So let us begin with steps. There are very simple steps. In this circular disc at the bottom, we have to make a hole in the center, a small hole in the center. I am using this pencil. You may use even a ballpoint pen or a pencil or any such needle or something, and making a hole in the center of it. I have made a hole. So this hole, you can make it little bigger. I'll make hole to the second bowl also, this paper cups. I'm making one more hole here. Now we need to pass threads, ends of thread into these two cups. So I'll be passing it from lower side. If this hole is too small, I'll have to use some pen to enlarge that. So I could pass it through the hole, and we'll put one paper clip so the thread will not come off again. I'm just making a knot here. The purpose of paper clip is only to lock this thread into the cup. This is a paper cup, so I'm just locking it. Okay, I'll go to the other end of the thread and we'll pass that through bottom of second paper cup. Okay, so I could pass that through the bottom of it. We'll again tie one paper clip onto the other side, make a knot. We may try to make two knots here. So from two sides this is connected. We will then, I'll stand up, take help of somebody, and we must keep it stretched. So when it is stretched from two ends, one will talk into the cup and other will of course listen to the communication by holding it over the ear like this. So one person can talk, one person can listen at a time. So one-way communication can be achieved with this simple string phone. We'll see its demonstration. So I'll talk through this cup and these vibrations will travel through stretched thread. It should be straight. It should not be loose like this. And Nikita on the other side will be able to listen to what I talk to her. I told in the discussion that newborn baby or baby at young age up to 1 or 2 years of age makes some funny sounds. As I told you, there is vocal cords and this complete system of communication is not fully developed. we'll see how exactly these funny sounds are made using a balloon. I'll just blow the balloon. So always to blow the balloon, it is better to stretch it this way. So you are softening it, blow it then. Now this is something like your lungs. Lung is filled with air, you know. And when we exhale the air out, it will come out from windpipe through vocal cords. If I imagine that these vocal cords are like stretched strings, and through these stretched strings air comes out, and that force of air makes these strings vibrate. So vocal cords vibrate and these vibrations produce sound. Let us see whether we get similar sounds by stretching this rubber opening of this balloon and letting the air come out. So is it not resembling to a child, very newborn baby, making some different funny sounds? Same way, in reality also, these two are the strings, vocal cords, they vibrate, they produce sound. But gradually after 2 years of age, child can make sensible sounds which anybody can understand them. We know that sound creates waves. That is what we have listened. But can you ever see these waves? You cannot. Waves are not visible. But we'll try to see effect of these waves so as to appreciate, yes, there are waves and which hit different surfaces. For this experiment, I'll use this paper roll, stretch this rubber sheet around its mouth like this, and to keep it stretched like this, we'll apply some rubber band around it, 1 or 2 rubber bands around it. I'm taking one rubber band, giving a round of it around it. The first round is made, I'm making second round, and I may make one more round using same rubber band. So this is now stretched rubber sheet. Stretched rubber sheet, which is like drum. I'll do one thing. I'm taking some salt. You may take even some sand or any such powder form, and I'm sprinkling it on very little. There should not be crowded kind of particles, just one particle at a time. Okay, I have sprinkled a few particles on top of this. Now one very funny thing I'm going to do. I'm going to bang this steel plate using this steel spoon, not touching this table. I'm not touching this plate to the table, just I'm going to make some sound, and these sound waves, they'll hit this stretched rubber sheet. It will vibrate, and the vibration of rubber sheet will be given to particles, and they will also jump from their places. So let us see if it happens. Take a look. Could you see easily that it simply is dancing on top of this, this rubber sheet, which is a stretched rubber sheet, so these particles were dancing. That means the waves were hitting this membrane, moving up and down, and that motion was given to particles, so they also started jumping. Is that not a wonderful way of understanding that sound waves are there, and though we can't see them, we can feel their effect, right? So this is about sound waves. I'll do some activity which perhaps you also might have done before. Making some sound using anything like a bottle. We know if I touch its top to the little lower than my lower lip, like here, little at this level below my lower lip, and I blow air across, I can produce some kind of whistling sound. Listen to this sound carefully and try to remember that as well, because we'll be wearing this sound very soon. So remember this sound once you listen to that. I'm just holding it below my lower lip and blowing. So remember the pitch. Pitch is nothing but that level of sound that you must, you have heard that, you know. I'm going to add some water into this, not full, little level of water. After I add water, first thing, will it produce some sound? Most probably yes, it will. Will it be higher in pitch or lower in pitch? No idea. We'll see. Some water is added. You remember the previous sound. Now listen to this. Same method, putting it here and blowing. So slowly it has started resembling to train whistle of olden days. Okay, so earlier, the trains, particularly those steam engine trains, were making this kind of sound. I'm going to add some more water into this now. Not exactly to a half a bottle, but somewhere close to that. Okay, I filled water up to here. You remember first two sounds. Now there's a third type of sound I'm showing with bottle filled up to less than half. Listen again. Got it? Okay. One more attempt. Adding some more water into this. Now exceeding half limit of this bottle. So little over half of the level. Let's try. Have you noticed that with level added, water level added, the pitch of sound is going higher and higher and higher? One more attempt I will do. Try to add some more water. Almost 2/3 or more than 2/3 bottle is filled with water. I am trying to blow it again. Still higher. Some kind of irritating sound as well. Right? Should we try one more attempt? We'll just try to fill it further, but now perhaps when I blow air, water may spill out. Because now it is so full that water may get that force and it may just come out. So, but still we'll try. Okay, it's quite high pitch. Try this. We'll discuss it next time. Without water, sound was very low pitched sound. With each level of water, the pitch kept on increasing, and finally it became such that perhaps it was irritation to your ears. Correct? Now this is about producing different sounds using water level, changing water level. In this activity, we will be making sounds using this plastic tube. I am making this tube straight, and then we'll form a U type of structure of this tube. We'll fill water up to some level. Let me just fill this tube with water. Okay, I filled water in this tube. Now next thing I'll do is blow air into one limb of it or one side of it, and when I'm blowing air, I'll just raise this tube up and down, other limb of the tube up and down, and see if we can produce some different sound by changing level of water inside this tube. So listen to me quite carefully. Is it not funny? Yes, it is indeed. But a beautiful experiment of changing pitch of sound by changing level of water inside this tube. I think you can trouble your parents a lot by doing this activity at home. Do try it, because science is science. You have to do activities, you have to enjoy them, and you have to show it to your parents as well. Though sometimes irritating, but okay, for some time it's fine. Show them how exactly this sound changes. Now I am going to do this activity, which is, you should be very careful while doing it. Same strip, plastic strip, which we used in one of the activities earlier, I am using here. I have tied a thread. Here I am taking 2-3 knots. Okay? Keep some length in your hand like this, and you have to swirl it over your head quickly. You will find it produces vibration in air and produces wonderful sound. So I'll be swirling it over my head like this. You have to listen to the sound that it produces. Could you listen? I'll just show it second time. You have to do it very carefully.